Okay, we got the car going in this direction. Okay, we got the bus okay, that's supposed to be a bus, and it's going in that direction. Okay, now if we add these, it'd be the same as if, see, we could add the motions. See, eventually they're going to travel to this. Let's say this represents 275 miles. I'm going to draw the car over here actually. Let's say at the point, okay, now at this point we're going to say that the bus here and the car here are 275 miles apart at this point. Now all of this would be the same as if one car, or one single car, drove the entire 275 miles, starting from that point, starting from the beginning point. Meaning, if I were to start it from this point and went all the way 275 miles, it's the same as two objects traveling in the center of that distance and going outward. It's the same. Okay? So, now to find at what time, the time is something that's the same for both. See, we're being asked to find how many hours. The time component is the same for both. Okay? Time, T, is the same for both the car and the truck. See, the car, see, we can put its distance formula represented by D equals S by T. That's 275 miles equals the speed of 50 miles per hour times the time, which we don't know. That's how many hours. The bus is D equals S by T equals 275 miles, but that's 60. And then the time, T. See, we're looking to see what time it is. Okay, so now that we have this information, so we have a chart, D equals ST, we're going to use this information. So we know, of course, the time is going to be the same for both, but we don't know it yet. So but we do know D. We do know that the distance is the same for both motions. For the complete motion, I mean. Because of course the bus, if it's traveling at 60 miles per hour in the same amount of time that the car is traveling at 50 miles per hour, we know the bus is going to cover more of this distance than the car is. Okay? I want to show you, just like we showed on the last two examples, how to apply the distance formula, and the fact that we know that the distance is the same here. We got two different speeds, but we know that the distance is the same, so that's what we use. We use that fact, we use that knowledge, the fact that the distances are the same. Okay? I just showed you the time is the same for both. That's what we're trying to find, but what we're going to use to find it is the fact that the distances is the same for both. Okay, so or we're going to say the total distance. So the total distance is 275 miles. We'll say total distance. Okay? Total distance equals the distance made by the car and the distance made by the bus, which we wouldn't know because we're not given a time by which to calculate our speed to find the distance. But we know that at a certain point, they're going to be 275 miles apart. Okay? So, we don't actually know the distances, but we know the formulas. So 275 equals d sub 1, which is 50 by t, okay, plus d sub 2, or the distance by the bus, which is 60 by t. Okay, now we have our formula that we're going to find our answer with, which is this right here. Okay. Now all we have to do is solve for t. Now that's 50 by t. That's, of course, that's 50t plus 60t. 275. So that's 50 plus 60t. 110t, which is time. Okay, so now we're going to do, now we divide both sides by 110. So t equals 275 over 110. 275 over, or divided by 110, that's 2.5. Or 2.5, or 2.5 hours. 2.5 hours, and that's our answer.